Okay, today I want to talk about something completely different. Let me get a share screen going. The issue of underwater scenes. Um, the standard assets come with the Unity Water Pro. It's, of course, no longer Pro only. It works for all of us, and it's a very cool way to simulate realistic looking water. And it's based on a fairly complex script called Water that you can look at, and it runs a custom shader, FX Water, and it has a number of interesting options. It allows for a very simple, probably cheap to render water that it still moves and everything, but there are no reflections or refraction. There's a reflective water where mountains in a different distance are reflected off the surface of the water. And there's refractive where you can see down into the water and the light is bent as it passes through the rippling water surface. There are other options for whether pixel lights are included. You can also adjust the texture size for the reflective and refractive cameras. This, like the mirrors, is using virtual cameras, not virtual cameras, but invisible cameras that are taking pictures to be then rendered as texture on the surface of the water. It's all very fancy. And there's also culling options. The custom shader FX Water requires 3 textures. One is called a Fresnel, and this has to do with the balance between reflection and refraction as a function of incident angle. When you're looking straight down into water, you see down into it. When you're looking at a grazing angle, you see more of the reflection, and that's called the Fresnel effect, and that's the there is an alpha channel gradient that determines that balance. I believe we can see one of these in one of these scenes here. We've got water here, and here's the clear water. That's not a good one. Well, anyway, there's a Fresnel. If we look at the prefabs, maybe that'd be better. Yeah, well, it's still pretty much the same. There's a normal map, which provides the bumpy appearance of our surface. This is actually modified procedurally. Then there are 2 wave speeds represented as a vector 4. So this is the X and Y of the first of map 1, and this is the X and Y of map 2, and then color and a horizon color and so forth. A lot of interesting settings that affect the waves are not accessible from those exposed variables. And so I have a sample scene. It's a water scene sample. Water scene sample. Oops. Water scene sample. Right here. Where I've instrumented this to allow you to fiddle with the different parameters, the wave scale, the amount of reflection distortion, and the different wave speeds, map 1 and map 2. And these can let you kind of change the character of the water. So changing the wave scale up to 1.15, it's kind of higher frequency, and down to 0.2 something, it's now much longer wavelength. So this is kind of the frequency of this in some ways. And then there is the amount of distortion in the reflection and the amount of distortion in the refraction, and then the wave speed in two simultaneous directions. You're specifying an X and Y that give you a vector direction and a magnitude of the speed. And so all of these are things that you can play with. And I'll let you play with them yourself. But how was this done? Because these aren't exposed variables in the shader or in the water script, we have to access the shader properties ourselves. And accessing the shader properties is done through the get and set calls. The XXX there is what kind of variable it is you're getting, an int, float, or a vector. So for instance, to access what the current wave scale parameter is of our shader, I use material get float underscore wave scale. To access that vector 4 wave speed, we need a material get vector wave speed. In shaders, vectors are all vector 4s. Note that in one case we have an underscore wave scale, and in the other we don't. We just have wave speed. This is because this is a custom shader and it doesn't necessarily follow all the conventions that one might expect. Looking for the reflection distort and the refraction distort, I've got to look for underscore REFL distort and REFR distort. And the way that one finds out these properties is to explicitly look in the shader, edit the shader, and look at the properties to see how the exposed variables look in the shader properties. So here underscore wave scale is what shows in the inspector as the wave scale with a range and a default value. Reflect distort is another range, a slider. Wave speed is just the wave speed. It's a vector with, by default, 4 values. So in order to know what variables you're going to get or set, you have to actually look explicitly in the shader. So where get XXX fetches values from the shader, set XXX replaces them with our modified values. So when I wanted to change the wave scale, I changed I changed wave scale, and then I assign it to the shader by doing a set float. And the same for any of the others here, including wave speed that doesn't have that underscore. So all this is great if all you want to do is look at the water, if all you want to do is look at the water from above. But as with most shaders in Unity, the water shader is one-sided. That is, if you look at it from the backside and you see its back face, that is culled and we don't see it. So in a situation like this with a piece of single water, if I walk into the water looks fine from above, but as soon as I get below the surface of the water, I can't see it. It disappears. It's a one-sided texture, as are most textures in Unity. An obvious solution is to put a second water object in the scene and flip it by 180 degrees about one of the horizontal axes. But because the reflection and refraction are implemented with these virtual cameras, they're not Cinemachine virtual cameras, but virtual cameras that are taking photographs to then map onto the surface of the water, it doesn't work because the water is expecting to be able to see through its backside to take the picture that it's going to map onto the surface. And if the other water layer is in the way, it doesn't get a good picture. So it sort of works. Here's two waters flawed. And if you notice here, I've got a Water Pro top and I've got a Water Pro bottom that I've flipped by 180 degrees. And so now when I walk into the water, I can see the surface of the other water, but you'll notice that it doesn't have like proper reflections. I'm not seeing a reflection of the checkerboard floor here in the surface of the water. I'm not really seeing good refractions here. Well, you sort of see little ones, but you're not getting good reflections. So clearly this is flawed. And what I want to do is take control of which water surface is active, depending on where the camera is, whether it's above or below the water surface. This is the approach that I've used with the Ripple Manager script that you'll see as I go along here. And I decided as long as I was controlling what I would see from above or below, I may as well add 3 other effects that I feel like simulate underwater behavior. One, of course, is fog. Water absorbs much more light than air does, and so the fog effect is good. It's also darker, so dimming the lighting. And while I don't think it's physically realistic, I think having the water kind of ripple in front of you when you're underneath the water would be an interesting effect. Fog is relatively simple. It's a unity effect that's controlled in the lighting menu. I'll show you the Unity standard fog. I decided to use something from one of the old Unity 5 standard assets called Global Fog. This is an old script with a custom shader that does much more with fog than just the basic fog. The light intensity, I'm just going to access the directional light in my scene. That's the scene's sun. And ripples I'm going to implement by using one of the custom shaders that comes with the effects. It's the stained glass effect with a bump distort. I'm going to use the shader. I'm not going to use stained glass. Now, this particular shader takes 2 textures. One is a tint color that would be for the color of your glass or whatever the overlay texture is. And the other is a normal map that kind of expresses the bumpiness, the rippledness of this glass. And for this, I'm going to use some Perlin noise. This is just a snapshot of Perlin noise that I found somewhere on the web. You can read more about Perlin noise at any point. And I'm going to import this as a normal map with the Create from Grayscale checked. And this brings it in with the red and blue channels indicative of the distortion of the surface that is used in the lighting calculation. The mesh is not really being deformed. It's still flat, but it looks like it has bumps on it that are mediated by the red and blue channels. If you take COS 460, you'll find out how this actually works. So I use this with the glass shader to make a material, I call it Perlin Ripples, that I'm going to just put on a flattened cube that I place in front of the camera. So my camera is looking through this Perlin Ripple glass shader with bumps on it. that is going to distort things in exactly the same way, actually, that the water surface ripples appear. But a static piece of bumpy glass is not what I want. I want it to wave back and forth, to ripple in front of the camera. And for that, I need an animation. And this animation can vary the tiling offset of the normal map texture and the Pearl and Ripples material. This is one of the settings in the material for the Pearl and Ripples. It has a tiling offset, and I can access this through scripting, and I can make this tiling offset move so that the ripples move. After lots of fiddling to get a setup where you didn't see the edges of the textures wrap around, and where the motion didn't seem like it was just ping-ponging back and forth, I end up with a nice rippling surface. So I'll come back to that and show you the example in a minute. So I have these two water surfaces. I have the fog set up on the camera with a global fog effect script. I have my Pearl and Ripple distortion cube out in front of the camera. The cube is called Ripple. All I need to do now is coordinate which things are on and which things are off, depending whether the camera is above or below the water. And this is done in this Ripple Manager script, which I may as well place on the Ripple cube. A bit of trickiness necessary to access the global fog script because it uses a namespace and it's not itself a mono behavior. It's an extension of the post effects base script. And so in order to have access to the fog, I have to do Unity Standard Assets, Image Effects, Post Effect Base, and that's the type that I'm accessing. In Start, I'm going to catch the light's intensity because I'm going to be turning it on and off. I'll set the fog mode, catch the camera's transform. That's what I'm testing to see if it's above or below water level. The distortion cubes renderer, the global fog script. Here's the global fog script with all that big long stuff. And I'm going to call test fog, which contains all of the logic to turn things on and off. And this will also be updated in the update function, called in the update function. So test fog, if we're at or above the water level, I'm going to turn the fog off, turn the distortion cube off, set the water top to be on and the water bottom to be off, and reset the light intensity to its default value. Otherwise, if I'm below the water surface, I'll turn the fog on with a specified color, turn the Ripple Cubes renderer on, turn the water top off and the water bottom on, and reduce the light intensity. One other effect that I added was a post-processing stack effects with vignette and depth of field, and actually the one I'll show you has some color grading as well. And I did this so that it would look more spooky underwater, and it would look like we had a kind of dirty mask on. And this, of course, requires a couple of additional steps, because to use the post-processing stack effects, we've got to load it from the package manager. It's a Unity package. We have to add a post-process volume to our scene. And these post-process volumes can either be global, in which case they act everywhere, or they can have a collider that determines the range of their influence. Um, so I'm going to use the latter. So I can make an empty game object that has a post-process volume component on it, and that collider. I don't think it has to be set to be is trigger, but you can. And its dimensions, the dimensions of that collider, define the volume within which the effects of the post-processing stack are active. So the stacks look something like this. We've got the different effects, vignette and depth of field are the two that I show here. I added some others for the demonstration here, grain and color grading. This is the object that you have to add to, um, you have to put it in a custom layer. I've called it PV volume. And the reason for this is the warning that you get if you don't do this. It says, do not use everything or default as the layer mask as it slows down the volume blending process. Put post-processing volumes in their own dedicated layer for best performance. So this object, first-person character profile, is in its own layer. I then size and position that volume so that it contains the entire underwater space. This is pretty cool because there's no need to do any scripting to turn anything on or off. This just takes care of it for you. The post-processing stack used to have a deferred fog effect. It's still there in the package folder and documentation, but it doesn't really work that well. It's been broken apart. I'll talk more about fog in a subsequent lecture. So I've used the global fog effect. You can see, so let me show you these. I've got a menu here so that I don't have to open and shut scenes. Whoops. So I showed you the single water. One I didn't mention is water 4. Water 4 is very laggy, but it is kind of cool because the mesh is actually distorted, and so that it has waves that are actually distorting the mesh. It's probably why it's so expensive. And it is two-sided without having to do any fiddling. I showed you the water flawed and the water fixed. Here's a dark water with just a different color for one of the textures in the water material. Here it is with just the fog turned on. So now when I go underneath the water, I have this nice fog that makes things diminish with distance here. So I get this real pronounced distance effect. And of course, the fog disappears when I come back above the surface. If I add the effect of dimming the lights now, now the lights have dimmed. So up above, it's nice and bright, but down below, it gets kind of dark and spooky. And here, finally, is with everything going. So I have my surface, my underneath, the dimming of the lights, and my rippling effect of that glass in front of the camera. So everything's working here now in this scene. I showed you the water sampler. This is what simple Unity fog looks like. It kind of puts this. You get to choose the color, but it puts this stuff out in front, and it has the problem that it doesn't put the fog in front of the sky. So it only puts the fog in front of opaque objects. So that's a real problem. This global fog script I mentioned, I think I mentioned that it has this capability of making kind of a valley fog. It has a height setting. So there's only fog down deep in the valley here. There's no fog when we're up high, but it gets thicker as we go down in. So that's a cool effect of the global fog. Global fog with distance. Here's the difference between global fog and Unity's fog. Has this problem where it doesn't put fog in front of the skybox, whereas the global fog does, so that we now have fog everywhere. And finally, here's the processing stack version, which I kind of got carried away with making it look really weird underneath the water. So I've got a grain texture overlaying my goggle view, which is done with the vignette. The color grading is all very weird. There's fog, there's bloom lighting. Uh, uh, the post-processor stack is pretty cool. It does a lot of stuff. So I'm gonna come back above water. I'm gonna stop this, and I'm gonna stop sharing, and I'm gonna end the recording, and I'll see you all in class. Bye.